take a look at number 69. And so we want to, down below, identify what the A and the B values are in terms of them being positive or negative. Now, if we look at our general shape of a tangent function, which we've been progressively working on in the last 4 or 5 problems, let's take a look at this again. When we look at these cycles, it's moving from left to right as it increases, left to right as this increases. And so I see that exact same shape. Now watch really quickly. If I would change the value up front, right now it's a positive 1, but notice if I would change it to a negative 1, we can see how it flips, right? So I can see the same basic shape is occurring if I come back here. This same basic shape is occurring, so I know that this value in front is still going to be positive, which allows me to cancel out C and D. What has changed is, if you recall from watching the last videos, as we talk about the asymptotes of the parent function. So here's the parent function, and hopefully you have watched 64, I believe is where it started, or 65, I believe actually it was 65, all the way through 68. We talked a lot about how the very first asymptote to the right of the origin for the parent function starts at pi over 2, and then we continue to add pi to the left or right to find the other essential vertical asymptotes. And so this is the parent function, but we can see this has been changed. And so it doesn't say to me what is the value of B, we just need to know, is it greater than or less than 1? So here, this very first one is not at pi over 2, it's at pi over 4. Now think about the unit circle. Here's pi over 2, but now it's been squished down to pi over 4. So that cycle has been squished. It used to take one cycle, took this much to make this shape, but now it's been squished. So I need to know what value went in front here to squish it. So it changed from pi over 2 to now pi over 4. So here's what I'm going to do. I'm going to say pi over 4 times what value gives me this pi over 2, right? So what am I multiplying by? Okay, so then I'm going to multiply here by 4 over pi. I'm multiplying by 4 over pi, and I get whatever this value is 4 over 2, which is 2. Okay, that tells me that this B value has to be 2. This B value has to be 2, which makes it greater. Now, I know this is not a calculated problem, but I do want to illustrate that. Pi over 4 to 3 pi over 4. Again, let's think about this unit circle. Here's pi over 4. Here's 3 pi over 4. This is a distance of 90 degrees. Remember, 90, 90, 90, 90 makes up 360. So 90 degrees is equivalent to pi over 2. So every pi over 2, I should be having a new cycle. Every pi over 2, I should be having a new cycle. So if I come back here, I'm starting my first asymptote as at pi over 4, and then I'm adding to it pi over 2. So I can come over here and I can continue to add plus pi divided by 2, or I could take and subtract the pi divided by 2 to go to the left of the origin. So I should be able to also subtract, and you can see, oh, I like to make things pretty. Let's come back here. I like to make these things pretty so they're all the same color. But we can see if I zoom in here, we're able to see that each cycle is then separated by those asymptotes, and here would be our general equation up above, is that our very first one, although they don't ask for this, our very first asymptote, if we had to say where do the vertical asymptotes occur here, it would occur at pi over 4, and then we would add to that pi over 2k. But this specifically says the A value has to be positive, it has the same basic shape as our parent function, and we determine our B value to be 2. We can see the math over here, how we achieved 2. 2 is greater than 1, and that's how I got an answer of A.